with this. That's it. So real quick here, welcome to chapter 10, the last chapter in the textbook. Yay. We are going to go into a little bit more of graphing, a little more in depth, something we probably didn't see before. And we're going to connect all of them together. All the stuff that we've been doing connects together. So real quick here, what are we going to do with the time remaining? Oh, real quickly here. Yes, Camille?
Is this going to be on the final?
Yes, So we're gonna probably only be able to get to 3 to 4 sections here. So I'm gonna go with 1 today, right here. At least we'll see all of them. We're not gonna get to rotating them, but at least we'll see all the pieces of it. We good? That's kind of what we want to see first, and then we'll jam. Okay.
Wait, is this geometry?
It's called analytic geometry, so it's analyzing graphs, not a certain way that you would think they are.
As long as it's not actual geometry.
Nah. So we're gonna go a little bit further into geometry. Okay, let's begin. So first things first, I have a circle on my hands. Don't need to write this out, not yet. Let's label all these actually. No, let's label all the stuff that we're going to be doing now. So we're going to be dealing with circles. Are we going to be dealing with circles? So we know how to deal with circles. We did that already earlier on in the semester. We're going to finish this off with something called parabolas, ellipses, and hyperbolas. We good? So we have ellipse. Ellipses goes like this. It's the way planets revolve around the sun and something in space. Then we've seen this one before, parabolas. We've graphed a parabola before. Let me spell it correctly here. Parabola. Ooh, and this one is an interesting one. This one is hyperbolas. They go like this. It's kind of almost like it goes straight and then turns and curves away.
Isn't that not a graph?
Ooh. That is right. Some of these guys are not functions, right? They're not functions. Notice the circles, do they pass the vertical line test?
No. I mean, if it was like 2 that was split in half.
Yeah, they
like
do.
Straight where it wouldn't go over, but that's hard.
And then let's do some other ones here. Let's check this out. This little guy is just called a point. That's how we graph lines, right? And then we have a line. We have a line by itself. And then we have this right here. We have 2 lines that just sort of cross each other. So intersecting lines. So in chapter 10, we're going to cover a little bit of parabolas right here. So I'll put a star next to this. Ellipses, hyperbolas, but this other stuff as well. How do these all fit together? That's what we want to think about. How do these all fit together? Neat stuff. Waiting for the punchline just a bit here. There's a punchline. Today there is. They all fit in this little guy right here. So this is called we call it conic sections. It's just 2 cones touching each other. And if you go like this, notice all the stuff that we just covered could somehow be sliced into this. So 2 cones touching each other right at the end. There's your circle. Circle is just a cone that's sliced perfectly horizontally. An ellipse is just a cone that's sliced at an angle. A parabola, we've been drawing parabolas for a while. Parabola is really just a cone or a slice of a cone that is parallel to the side itself. And that's how we get parabolas in a very generic sense. Hyperbolas is a horizontal slice through a cone or a double cone. And this one is the only one that we actually need a double cone for, right there. A point. We think of a point as just a point in space, but it really is just when the cones touch each other, right there. There's our point. And lines, we've been graphing lines all this time, but lines could just be the outside of both of those cones or the extension of one line. And same thing here. So it's crazy how all this stuff that we've been studying so far actually fit on this one cone-shaped thing that we've been dealing with here. So today we're going to deal with lines themselves, just lines, just this piece right here. And then we move on to, I think ellipse goes next. This one or the parabola goes next, I think. Let's see. Yep. So we're going to go this one, we're going to go this one, and this one to finish off algebra 2 in. Okay. It's called analytic geometry because we're going to analyze a little bit more concentration than just graphing a line, right? We know how to graph a line. Now the question is, hey, what's something else in here? Same thing with parabola. What can we do with parabolas that is more than just getting dots on a table, putting the dots on a sheet of paper, and connecting the dots together? Let's jam. So first things first, when you have two lines crossing each other, actually, we're going to be more like doing this right here. Two lines crossing each other, as well as dealing with stuff in a line. Have your calculators, maybe? Do we? Inclination. Okay, let's talk about, we'll get to calculators in just a second. I just want to have them out here. So we're going to deal with, in this section, we're going to deal with inclination, angles between lines, and last one is distance. And we can actually know between, okay, a point and a line. So we'll do those, and we're going to jam very, very quickly here. So inclination, we'll know what that is, we'll find out. Angles between lines. And then we're going to deal with the distance between a point and a line right here. So that's a lot of stuff to cover in a half an hour. Let's jam first things first. What is inclination? What we think about inclination is maybe a few graphs might help here. So it's an angle measurement. So just like walking, and it's also something called radian measurement here. So let's talk about that first. So a few things to introduce. So we could talk about degrees. Oh, it does it in degrees as well. And it does it in angle measurements too. Let's see. I'm going to just check real quickly on the notes here. Let's see if they do it in radian measurement as well. Okay. So few examples here. Ready? If this is a line right here, then this, we call it theta, because now it's an angle measurement. And this is 0 degrees. And it's talking about how much it extends from the x-axis. This guy here, if we go straight vertically on us like this, we can say that this is 90 degrees. There's also, do you guys, have you guys done radian measurement before? This is called pi over 2. We'll get to radian measurement in just a second here. That's the two different types. The generic side is this right here. The generic side is this line is somehow going through like this, and it's the angle measurement right here. It's what happens between the x-axis and the line itself.
So if it was like a negative slope, it would be like over 90 degrees?
Perfect, yes, so that's less than 90 degrees. One last figure that I could squeeze in is this one here. If it goes like this, it's going to be more than 90 degrees. Okay, are we good there? Okay, and we're gonna still jam. Okay, radian measurement. Let's talk about that here. Radian measurement. So if you were to get a circle like this going, there are 360 degrees in a circle. So if you go from 0 degrees, it's going to be the same side where you see 360 degrees. A funny thing that happens, we'll explore it more in trigonometry here, but if you were just to measure the outside of a circle versus its diameter, so how about this? You take the circumference divided by diameter. You just do that right there. So let's say this is 5 feet out, and you would take this length measurement right here, 5 feet, and you place the 5 feet right over here. It'll be about that much right here. That's so 5 feet here and 5 feet there. We good? Yeah.
What is that graph showing?
Say again.
What is it showing?
This little graph?
Yeah.
We're just talking about radian measurement for now. What is radian measurement?
So is it saying that that curve, though it's labeled 5 feet, is the same length as the axis?
So I have an X and Y plane. This is my Y value. This is my X value. And I have a circle that's drawn. It's 5 feet out from the unit circle, just as an example. We good?
So then, but then what is the curve that has the 5 feet on as well?
Oh, perfect. Yeah. So I take this little radian measurement here, and I lay this exactly perfectly right here, right on the outside of the circle.
So those are equal?
Those are equal right now. Cool. I lay another 5 feet. So this is my cutoff for 5 feet. Let me lay some more. Let me lay another 5 feet. So now this is 2 right here. That's another 5 feet. Then I'm going to lay another 5 feet down, and it goes just like about right here. There's my another 5 feet. And they got this extra little piece right here. And whenever we do a decimal approximation from that, it turns out to be, it's a decimal approximation of about that much more. So it's about 0.14 units more from the 5 feet. Good there? Interesting. So hold on, how many 5 feet do we have? Three of them, right? So technically, how many radii, it takes 3.14 to go all the way around the unit circle.
The circumference is what's the equation for circumference? Something with diameter and pi, and radius is just half the diameter, and that's covering half the circle.
Perfect. Okay. So Owen says circumference formula. You guys remember that from geometry? Is 2 pi r. But if r is 1, then your circumference is just 2 pi. Okay, good. So this is what radian measurements are. Let's talk about them. So if you go all the way around, you have a radian measurement of 2 pi, or about 2.68. If you're exactly half the circle, you'll be at exactly pi, which is 3.14. If you're at exactly 90 degrees, you would be at pi over 2. Anybody real quick here, pi over 2 in your calculators, what is pi over 2? So there should be a pi button on your calculator somewhere. Oh, perfect. Okay, so about 1.57. Okay. But we would label it as pi over 2 if we want an exact value. One more thing. Can you guys do for me? What is this right here? This would be half a pi. This would be pi. So this would be 3 pi over 2. What is 3 pi over 2 approximately? Okay, how'd you get that, Isabel? What'd you do? Okay, got it. Take 3, multiplied by pi, divided by 2. Yeah. We could also just say, look, it's a quarter circle plus a half circle, right? 1.57 plus 3.14 makes 4.71. Add them up. Okay, cool. Are we good there? There's radian measurement. We're also going to work in degrees. Degrees you guys already know. So let's go with it. Example 1. Let's find the inclination of 2x plus 3y equals 6. So what we want to do is if I let me real quickly, if I were to graph this line just real quickly here, if I were to graph this line, I think what's going to happen is it starts off at 2, it's going to come around right at 3. It's going to go like this. Pretty sure because I graphed it earlier. My question is this: what is this angle measurement right here going to be? What's the inclination of this line? And so what we want to see is two formulas that come out of it here. So notice it's above 180 degrees, right? More than 90 degrees. Thank you. Okay.
Do I have one?
Yep, no. It's more than 90 degrees. So let's see what happens here. First things first, on your calculator, see if you guys can find a button called TAN or TAN. The tangent button. Thank you, Charlie, for getting those.
I have tan to the -1.
Yep, and we will do those in just a bit here.
I don't know if I have tan just.
It should be nearby. Mine are right next to each other.
Oh, wait. No.
So we're going to use tan to the -1 because it's called the inverse of tangent here. So real quick here, do you guys notice that this is a slope right here? M is for slope. Can you guys tell me what the slope of this line would be?
-2/3.
So subtract 2x from both sides, divide by 3, and Owen is totally right. -2/3 would be it. So we're going to take this -2/3. Yeah, interesting. And we're going to plug into our little formula. Our formula says that tangent theta is equal to -2/3. Now, if it's above 90 degrees, because it's greater than 90 degrees, we're going to use an extra little formula here for it. On your calculator, make sure you guys are in degree mode, first of all.
How do you do that?
And so notice on top of your calculator somewhere you should have mode. It's probably one of the first buttons across the top.
I don't know. Oh, wait, is it one? For what, radian?
You want to be in degree mode. We'll switch to radians in just a bit here.
Oh, what did you say? There's a lot of
So,
moves.
yeah, right here. So notice this little mode button right here. You go down, this is the third one down. I think it should say radians or degrees. So with your arrows, you want to go down to radians, scoot over to degrees and click enter because you want degrees to be highlighted. And then you're going to quit out of there. So quit just means this little second function and the quit button. So you got actually second mode, gets you back to beginning. You good there? So tangent is a trigonometric function. We're going to learn more about it in trigonometry here. But for now, what we're going to do is we're going to figure out what our theta is. And our theta is going to be, if tangent theta is equal to -1/3, it's going to be tangent inverse of -2/3. So let's punch that into your calculator here.
Why is it inverse?
Because we're trying to get the angle itself instead of just getting the ratio.
So what would be different if we did it not inverse?
Then we would, if we knew the angle measurement, let's say, I'll show it to you in just a second here once we actually find the value. So tangent inverse is right here, tangent inverse of -2 divided by 3. Click enter and go for it here. Notice this has note it has a negative there. And again, not doing a lot of stuff with tangent, we're just getting two formulas out of it, right? What we're going to do is we're going to add 180 degrees to this. Click enter. And you have 146.3. That is the inclination here. Are we good? So if it's more than 90 degrees on our little value, it's always going to give us a negative
Why do
value.
you add 100 again?
The way tangent works, and again, we're not doing all of trigonometry here. That's the problem. There's a lot of pieces that are missing here because it's the way you define tangent in the first place. So if you're above 90 degrees, what we're going to do is we're going to always add 180 to it. Because it gets us back between 0 and 180.
So it's just tan, like,
Inverse
okay.
of -2/3. And you're going to know that it's going to be over, you're going to add the 180 because you have a negative value here. Everybody okay with 146.3? There it is. Your angle measurement is 146.3. That's your inclination right there. Let's do the same thing, but do it in radians. We good?
So if we switch the radian, will it change the answers?
Because remember, our answer is going to be, let's see, theta is equal to, see, how about this class? Let's put this in together so it makes sense. So if m is less than 0, which means the slope is negative, right? Slope is negative. What we're going to do is we're going to say theta is going to be equal to tangent inverse negative value, right, of m plus 180 degrees, or theta is equal to tangent inverse of m plus pi. If m is greater than 0, then theta is just going to be tangent inverse of m. You don't need to add the 180 or the pi.
How is m defined again?
M is our slope. Okay, so let's do this one now again, but let's do this one in terms of radian measurement. So, because on the homework it says give me both degrees and radians. Okay. See again? Yes. Okay, so let's go with let's go to mode here. Let's jump back to if you had radians highlighted last time. Let's highlight radians again. And we're going to go to second quit. And we're going to go to tangent inverse of -2 divided by 3. So now notice it's not going to give us -33 degrees anymore. It gives us a -0.588. That is the degree, that's the radian equivalent of 33 degrees. So now we're going to add pi. So find your pi button somewhere over here. It's usually above the caret button. It could be in a different spot. You click enter. It should be about 2.55. If you got 2.55, you did good.
Wait, what do we find?
We add pi to what we got earlier. Okay, that was the difficult one. Let's do an easy one real quickly here together. So let's jam to exercise 2. Find the inclination of y is equal to 2x minus 5. Minus 6. Let's do minus 6 just because it'll be easier to compute. Okay, let's draw it out real quickly here. Drawing it out. That's 1, 2, 3, 4, 5, 6. Somewhere over here. Up 1, over 1. So it's going to be, we're not being too careful how we draw it because we're interested in this little angle right here. So question is this less than 90 or more than 90? It's a positive angle. It's going to be less than 90 at this point, right? It's crossing at a diagonal going up. Okay, so let's go back to our little notes here. Let's see. If the angle measurement is positive, so m is equal to 2. So m is greater than 0. That's cool. So let's go radian measurement first, and let's go the other way here. So we don't need to add 90. We don't need to add 180 or pi anymore here. So let's go with tangent inverse. What's our slope over here? Just 2. Is that right? That's my slope. Enter.
Is this for radian or degree?
For radians for now. 1.107. That's what I got for my radian measurement. Talk to me. Did everybody get the same? Charlie, are we good? Tristan, we good? And Annette, are you able to follow on your calculator? You should see a tangent inverse button on your calculator, and you should see if you're in degree mode or not. So on this one, you're going to put 2. Second function should this one. Okay, boom. Let's go with ours. Let's go now in degrees. This is the radian measurement. Let's go to degrees. So click on mode, jam to degree mode right here. Click enter. Dunk, dunk, dunk. Now we're in degree mode, right? Let's quit out of it. Let's press tangent inverse of 2 again. And what'd you guys get? Blush, blush. I'm gonna pick on you guys. What'd you guys get?
63.4.
Awesome. Okay, so 63. Yeah, let's go 63.4. So there's your inclination for this one here. Is about 63.4. Now with degrees, you got to put a little degree symbol next to it. So that's the difference here. If you don't put a degree symbol, you're in radians. If you put a degree symbol, you're in degrees. Okay, jam. Is that interesting? Now, when we look at vectors, when we look at incline of something going higher with lines, that's exactly what we look at right here. We look at x kind of usually is our ground, and then the inclination is somehow going up from there. Okay, Tristan.
So I'm assuming there's going to be, well, you already said there's going to be problems like this on the would we be allowed to use like calculator?
Yeah. So final, I'm going to have to do like a non-calculator portion and a calculator portion somehow on the test. Okay, are we good there? Let's see what time we have. I think we can still make it. Let's go with it here. The second piece to it, I'm gonna go kind of quickly here, is angle between. Find the angle. I should write it out here. Between lines. And I'm gonna guys give you the formulas. We're gonna give you all the formulas here real quick here. The angle between lines is this right here. It's a bigger formula now. It's tangent theta is equal to absolute value, slope 2 minus slope 1 divided by 1 plus slope 1 times slope 2. Now, it doesn't really matter where it is here. Here's our little formula.
M2 minus M1.
M2 minus M1 on top, then it's 1 plus M1 times M2.
Is that absolute value?
And the absolute value on top of that, yeah. Because
Yeah, you can't have negative.
and whenever you say the angle between lines, unless they're hitting exactly 90 degrees, the angle between them are gonna be smaller. Okay, so let's do this here. Angle. I need to know the angle, find the angle between.
Is that just M1 or M1 that's plugged into?
Yes, on the bottom, M1, find, and the angle between, and let me give you both of them here. 2x minus y minus 4 equals 0, and 3x plus 4y minus 12 equals 0. So can you guys, real quick here, can you find me the slope of each of one of those lines? I think we can finish. We got 7.5 minutes to go here. So let's see if we can finish up these guys real quickly here. So I'm going to add 4 to this side. Is that okay? I'm going to subtract 2. So I'm going to go here plus here. So if I take the negative out, you guys talk to me. Make sure you keep me honest. Is that true? It doesn't matter which one is your first line or second line as long as you're consistent. Okay, between the two here. Okay, so I'm going to go M1 is equal to 2.
Wait, if you're multiplying them on the bottom, right, it doesn't matter which one's which. So you think it would matter because it's going to give you 2 different things, because you're going to have 2 different answers on, because it's absolute value.
Absolute value. I was going to discard it. I'm going to add 12, subtract by 3, so negative 3x plus 12. Divide by 4 gets me negative 3/4 x plus 3. My slope 2 is a negative 3/4. Every good so far? Okay, let's plug into that formula right there. Okay, so let's go with absolute value, or we can do absolute value afterwards here. Let's just get this 2, no, it's negative, right? It's negative 3/4 minus 2 on top. It's 1 plus 2 times a negative 3/4. Whoa, okay. Now, with this one, we can probably do the calculator to it. Just tell me, like, let's do the top by calculator. What's negative 3/4 minus 2? What do you guys get for that? Just the piece itself. I'm running out of space over here, so let me do it at the bottom here. Okay, can anybody give me just negative 3/4 minus 2?
Negative 2.75.
Negative 2.75. Thank you, Charlie. Okay, on the bottom, can you guys give me 1 plus 2 times negative 3/4?
As much as a half. Or negative.
Negative half. So negative, so it'll be a 0.5. True. You guys talk to me. I don't know. Let's see. 1. So that would be minus 6/4. So that would be minus 3/2. That'd be 2 minus 3/2 is a negative 1/2. We good there? That's absolute value. What's going to happen here? It's going to cancel off these guys. So eventually we have 2.75 divided by 0.5. So, could you guys give me that? 2.75 divided by 0.5. What is it? What do you guys get there? Oh, it's at 5.5. Is that right? 5.5. Okay. So eventually I get 5.5 out of this. Okay, now let's do this here. Let's go. Theta is equal to tangent inverse of 5.5. Give me that one. Okay, and we are in degree measurement. That's fine. We'll go in degree measurement here. So tangent inverse of 5.5. Awesome. I'll go with it here. Let's see. 79.7. Let's do that here. 79.7. That's cool. Okay, if I were to graph these two lines like this, one line going like this, the other line going like this, the angle between them is 79.7 degrees. Are we good?
So you're measuring that, not any of the other ones.
And we
There's
measure,
only two angles, because the opposite ones are the same, right?
well, these opposite sides are the same and
Yeah,
these opposite
those
sides are the same.
opposite sides are the same.
These guys are gonna be more than 90 degrees. These are less, and you're always gonna get the one that's less than 90 degrees.
Why are you gonna get the one that's listed?
Because we are using absolute values
Oh, right.
for tangent. And so the angle between things is usually the smaller angle. It's gonna be the smaller angle.
So, if you're up, what does the degrees mean? Like, how many degrees are between them? Okay.
So if you were to put a protractor down, right, you would measure
And then
79.7.
you got the lines from the equations that we used at the start.
Yeah, So we got that slope and that slope.
Okay.
Okay, one more formula real quickly here, and then we'll go. Is the distance between a point and the line. So now the question is this: how do I get? Now we only have time. I'm going to give you the formula, and that'll be it. But I have a line that's coming down like this. I have a point that's just somewhere right here in space. And what we can do is we can figure out the closest or the distance between these two. And what's going to happen is it's going to be the point that if you go straight toward the line, it's going to be this little guy right here. And it's going to be this little distance right here. Good. I'm going to let you guys try the formula yourself. But here's the formula. The distance between the points, or that particular point and that whole entire line right over there is going to be this right here. It's going to be the absolute value of ax sub 1 plus by sub 1 plus c divided by a squared plus b squared. Okay, crazy formula. It doesn't involve a trig formula anymore though.
Where
Okay.
did A and B come from?
And so let me go with it here. So all these pieces come from your equation. So if I have y is equal to, oh, hold on. Let me write it like this.
C is equal to A.
Negative 2x plus y minus 1 equals 0. You always want to have it equal to 0.
A, B, and C.
That's your A. The B is going to be a 1 technically sitting here. And C is going to be that little piece right there.
X and Y are the ones.
Yeah,
And the x and y, the x sub 1, y sub 1 are giving me the points that are right here. Okay.
that seems unnecessarily complicated.
But it gives you the distance and the shortest distance between them as well. Okay, I'm gonna leave you with the formula. I'm gonna give you guys homework though. Homework is gonna involve you guys calculating that. All right, and we are done.
I like it, Bernie.
I think I did too.
Yeah.
It's growing on me the more I learn.
Thank you.